Hello, Joe with SnapFab here for Certiflat Weldtables. Today what we're taking a look at is the new Fab Turn Weld Positioner from Certiflat. This is a do-it-yourself kit intended to give welders the opportunity to use a weld positioner for a fraction of the price of a high-end weld positioner. This is something that can certainly be used in a hobby or even in a production type setting where it just isn't necessary to have a really high dollar weld positioner. But good quality, good price is what we're basically looking at. First thing we're going to do is I've received the weld positioner and got all the parts out of the box, and we're just basically going to do what you should do when you first receive this is take a look at the papers that come with it, and basically we're going to get a parts breakdown of what should be included in your kit. There's also some images on the back there showing you part number one, which is the collar assembly, and then showing you an image of what that collar assembly should look like. Pretty standard stuff when it comes to a material list, so you know that you've received everything. So that's what we're going to do, is just have a look at what we've got here. There is one bag that contains bushings and collars and hardware and some small pieces. There is some key stock in there, some, like I said, bushings and hardware. Just be careful you don't lose any of this stuff. Set screws, a couple little roll pins, some plastic push pins. So if you have a magnetic tray, that's obviously going to be a good thing to try to put this in, because the last thing you want to do is chase a roll pin across the floor. So that's our hardware pack. It comes with the gear set. You got your 4 1/4 gear, 4 1/4 inch diameter gear, and then the worm gear for the gear reduction, the way those two will engage one another when it goes together in this kit. We've got 2 machine shafts. Longer shaft is actually the shaft that will work with the positioner plate. Shorter shaft, which should be our drive shaft that the worm gear will go on. So those are two machine shafts. They do have, there's a keyway, hex end for the drive, and then we've got some tapered holes for all the set screws to engage. So there's no guesswork as far as positioning the gear or the collars. That's already predetermined by the tapered holes for the set screws. The last Ziploc bag we have is our ground strap, so that the weld positioner plate is isolated to the chassis of this weld positioner, so none of the current from the welding process will be going through bushings, bearings. There's no bearings, I guess, but the bronze bushings, it's just, there's actually a hole at the end of this shaft that gets attached to this ground strap, so that your ground is basically, path of least resistance is right through the shaft for the weld positioner, not going through the bronze bushings. That's been a question commonly asked, is how is it grounded? So the ground is not through your bushings. It's directly through the shaft of the positioner. This is a little Velcro strap that's included. This, in the first videos of the weld positioner, it showed a cordless drill running this, and it had zip ties around the trigger of the cordless drill, and that was that was the first video footage of the first prototype. So this is a little bit better than that. Just a Velcro strap for adjusting and holding the trigger in place on your cordless drill. Since there's been talk of that on social media about how is it run, is it a cordless drill, a corded drill, this is certainly quick and easy as far as controlling a cordless drill. Other things that have been talked about online are, can you use a corded drill? Well, yes, you can use a corded drill. Any kind of drill that has a chuck large enough to, well, it's probably 3/8. I guess I'd have to put a caliper on that as far as the hex end of this shaft that your drill is to hook up to. Or you could use a socket drive, but yes, you could use a corded drill and a rheostat pedal if you wanted to have infinite control of the speed, by pressing the pedal, a lot like when you're using a welder, using the rheostat pedal to operate a welder. You could do the same thing with your corded drill and have complete control, start, stop, and speed. The reason it was intended for a cordless drill is, who doesn't have a cordless drill anymore? First package here are a couple sheet metal side plates. That's just basically non-structural covers for the housing of the positioner itself. Here is going to be the positioner plate. Been a lot of questions about this plate, if it was going to have drilled and tapped holes specifically for a 3 or 4 jaw chuck to hold parts in the positioner. The production version does not have any specific hole pattern for a chuck. So it's something that if you have a chuck or you buy a chuck, you can translate the hole pattern, drill and tap if you need to. So. In this package, we've got the basic, we've got all of the components to the main body of the housing that's going to hold the shafts and the gear set. We've got basically top and bottom, sides, and these are inner support structure. These two with the holes, there'll be a pair of bushings through there, so that's supporting one of the shafts inside the housing. And the last package here should be another sub-assembly, you could call it, and this is going to be the base and the main side plates for the base. That's our bottom plate, and then we've got side support structure. And all of this is unpackaged now for the first time, and you're going to have debris and contamination on here from the cutting process, so you're going to want to wipe this all down before you start welding. Take a look at the inventory in the hardware package here. We've got 4 bronze bushings, 2 different size bushings, so you'll want to determine which is which and where those are used properly. We've got 4 collars with set screws. These are for positioning the shaft within the housing. There's 4 of those. Couple shouldered bolts, nuts, a couple other bolts for assembly, set screws, roll pins, piece of key stock for the round gear, and then these plastic push pins, Christmas tree type push pins like used for auto interior, things of that sort. Those are actually used to hold on these final side covers to the weld positioner. So that's all of the parts we have for this build. The documents that come with the kit, like I said, one is going to be the materials list, and then there are 1, 2, 3, 4 more documents that basically lay out the assembly of the weld positioner, some specific dimensions that you need to be aware of. There's one sheet here that gives you indications of where you should be putting welds on the 2 different sub-assemblies. One being the gearbox and the other one be the positioner plate, or positioner base, I'm sorry. So there you have it. That's basically our materials. I'm going to clean all of these metal parts and then we'll come back and start looking at assembly. Right, the first step that we're going to take here are putting the bushings into the sides of the gearbox. I've got the 2 large sides to the gearbox, and there's a shaft that runs through both of these sides, and there's obviously a bushing that goes into both of these plates. This one is already in the plate. There is a left and the right, so we want to have bushings positioned correctly. So you want to refer to the way that these plates are laid out and reference how those plates will basically be positioned in relationship to one another, and put these bushings in. It's just a real light friction fit. You can press these bushings in or lightly tap them in like that. These bushings go all the way through this plate till they bottom out on the shoulder. And again, you want to make sure that you press the bushings in from the correct side so that you have a left and the right with the bushings in the proper spot. Just like that. Now there's the other side plates to the gearbox and these bushing support plates that go inside the gearbox, and the bushing actually passes through the one support plate and presses in to this plate and is flush on this side. So you basically have the bushing passing through this support plate and press fit into this side plate. It's like that. There's 2 of these side plates and 2 of these support plates. The plates are identical. There's not one that's specifically a left or a right, but it's pretty easy to line them up, put your bushing in, and we're just going flush with the outside of this plate. So I'm using the table to help me do that. Tap that bushing in till it's flush with the outside surface, and then this other plate is basically suspended there. So that's how we want those bushings placed. And again, one for each side. Those bushings will be facing inward, and the shaft will go through those two bushings. Same way they'll be going through these 2. Now, On these plates, you'll see two little holes below where this bushing goes through. Those are for the roll pins that are included with the kit. Both plates have those little holes for the roll pins, so it doesn't matter which one goes on which side, but you do want them to go in the correct orientation in reference to this plate. This hole down here is the actual hole that our locking pin goes through for adjusting the different angles for the weld position. But we're going to just use that as reference. If this little bump here, we call that, I'm going to say that should be facing down when you're determining the orientation. And these pins, these pinholes, should also be down. So that these two plates together with the bushing kind of engage the side that same way. You can see we got those plates in place. This corresponding plate. There we go. Took a little bit to get all of those to line up correctly, but once you get the tabs all lined up, you can see how those plates go in there. And the reason I'm putting it together like this is we're actually going to use the shafts kind of temporarily as an alignment tool. We'll put the shafts in place. And what I'll end up doing is I'll put this shaft in. I'm going to grab a couple of these collars with the set screws. Get that shaft in there, the collars, lining the collars up with the corresponding set screw holes. And now with that shaft in there and the collars on both sides where they're supposed to be, basically I've spaced the shaft in there with the bushings, and I know that my plates on either side are spaced in a way that the shaft is installed properly. So that I'm kind of using that to help fixture these four sides together for the welding process here in just a minute. And this is the other shaft. I'm going to use that for alignment purposes as well. Just using this shaft to kind of hone out this bushing just a little bit to get these collars in. Space the collars on this shaft the same way. Alright, it's a little bit of a puzzle to get those shafts in there and the collars, but we want to do that so that our spacing top, bottom, and side to side is right for final assembly to get these shafts in here when we put the shafts in with the gears. So these should, there's going to be some friction obviously because these bushings are brand new, because it should feel tight. Should be able to turn these by hand. That way we know that our alignment from end to end with the bushings is good. So yeah, that's really what's going to kind of help us keep this fixtured together and keep it all aligned when we weld. And then there's this last little support. It's kind of got a tab there. Some light taps to get that to fall into place. And these shafts obviously will be coming out at some point in the final assembly, but I just wanted to get them in here before I started tacking the gearbox here together, so that I know that the holes are lined up as they should be. Once you get to this point, just double check with the drawing that's included to make sure everything is oriented correctly. Really, it should only go together one way, and that's the right way. But once you get to this point where I'm at here, we're actually going to start tacking this together. As long as these shafts turn freely by hand, we should be pretty good. I'm going to probably do some light clamping while I'm tacking, just so that parts don't pull away from one another, but I'm not going to get too crazy with clamping to try to square anything up, because that's why we put these shafts in here. If the shafts are in place and they turn freely, you know, our box is going to be pretty square. That's just the way that all the pieces engage one another. Should square up. I will say that these little support plates on the inside that the bushings go through, we're not going to tack weld these. We're going to leave these kind of free floating within this box. So the tabs on the sides that belong to these short brackets on the inside that support the bearings, we're not going to weld those. Those are going to allow to just kind of sit there free floating within this box. With the instructions, there is a sheet specifically for the gearbox, and it does make note all of the welds that we put to this gearbox, tack welds and otherwise, should be on the inside, because this box here is going to pivot within the base and the two side plates to give us the adjustability to rotate the gearbox part of the weld positioner at different angles. So we don't want to have any welds on the outside that's going to interfere with that movement. So these two plates, the short plates for the bushings, do not get welded. The top and the bottom get welded to the side plates on the inside of the gearbox. So everything is lined up. I'm happy with the way it's positioned, so I'll get this set up to weld, and we'll weld the corners on the inside, and once it's tacked up, verify that these shafts still turn freely, and put a couple good finish welds on the inside, and we'll call this sub-assembly done. And I'll end up removing these shafts. We have to weld the round positioner plate that goes up top. That'll get welded to the end of this shaft, and we'll fixture this to make sure that the shaft is straight and true to that plate. So if you're at this point and the shafts don't turn freely, find out why. You won't have one. Obviously, once this is welded together, you won't be able to change it. So there we are. Alright, I've got my gearbox welded up. I've got several welds on the inside and on the bottom and the back side, some welds secured all together, and I removed both of the shafts out of the gearbox. Next thing I'm going to do is, this is the top plate, or the positioner plate for the top of this unit, and this is the drive shaft for the positioner plate. It should be obvious that we want this shaft to be perfectly perpendicular to this surface, so that when this positioner is turning, that it's turning flat and doesn't have any wobble to it. You know, if the shaft wasn't straight in the plate, then obviously the plate's gonna wobble back and forth when it's turning. So this is probably, I would say this is probably one of the most critical parts to get welded correctly. There's any number of ways that you can try to make sure that that this shaft is perfectly perpendicular to the plate. What I am going to do, I've got a couple fab squares that I bolted together, and essentially what I'm going to do is I'm going to clamp the shaft here in this 90-degree corner that I've created, and then use this flat surface to keep my plate flat, and that'll keep the plate and the drive shaft here true and perpendicular to one another while I'm welding it. So that's how I'm going to do it. If you have fab squares, then you can obviously mock it up the same way. If you don't, you can certainly use other welding squares, other blocks to fixture it together. There, I got one big C-clamp holding my shaft in this corner, good and secure. And this plate flat against the fab squares. This is going to be completely true. So all I have to do is weld that closed in the middle there, and we'll be done. It should be just that easy. Pop these clamps. And that guy is, I think, as perpendicular as possible. There is a correct end and an incorrect end to weld into this plate. There is a machined and threaded end. That is the end that will be going through the bottom of the gearbox that your ground strap gets bolted to. So make sure that that's not the end that you weld to. It'll be the blank cutoff end that will get welded to that plate. So that is complete, and what I'll actually be doing next is assemble the shafts in the gearbox along with the gears and basically tidy up the final assembly of the gearbox, and then I will use the gearbox to fixture the base and the sides where the gearbox pivots, and finish welding that up. Alright, we're going to start assembling the gear units inside the gearbox here. When you're assembling it, you'll want to refer to this drawing here, which basically is an exploded view of the entire unit. That'll help you with the assembly to make sure you get all of these components in the right order, because as this shaft is going into the box, all of these components, the gear, the collars, are going to get slid on there. You'll see as it's coming together. For assembly purposes, if we're looking at the side of the gearbox, you see this little ear on the back here. This is where the unit will pivot, and well, actually it pivots here. I'm sorry, it's going to pivot here, but this is where the locating pin goes through the box. But we're going to consider this ear, that this side is the back of the gearbox. So this is going to be the front of the gearbox. And if we're looking at the front of the gearbox, we're going to have the shaft enter the right side. So if we're looking at this as the front, the shaft enters the right side through this bushing. So for installation purposes, that's what we're going to do. The front of the box, shaft entering through the right side. Get this shaft started. First thing that's going to go on is one of the collars. And the next item is going to be this drive gear, worm gear, and the collar of the gear with the set screw is actually going to be the first, or going to be the second part of the gear. Let me get that right. So as the shaft is coming in from the right, it's going to go through a collar, it's going to go through the gear of the collar, and then one more collar, in that order. Hope I got that right. If I didn't get it right, I'll be shooting the video again. This is also where the key stock gets used. In that shaft there's a keyway and a keyway for the gear. Alright, it's a decent, I mean there's enough play and it's not a tight enough tolerance. You can drop that key into the keyway and slide the gear over the key, so we don't have an issue that we have to press anything. Now looking from the back side here, the shaft went in from the right side, goes through bronze bushing, through the collar, through the worm gear, and through another collar and the final bushing. And there are all these set screws that position everything, so we can slide our gear into place and tighten that set screw. And we know that's where it's supposed to be. Push the shaft in there some more. Line up this collar, lock down that set screw, and if we bottom that collar out, that should line us up for the other collar. Remember, that's why we put these shafts in there during the original assembly, is so that we had our spacing right on. Reference the collars to the bushings. So there's that shaft, turns freely by hand, and everything should be positioned just the way we want it. Now the next part for us to install is going to be the positioner top plate itself. Again, we're going to be going through the bushing, going through a collar, going through the gear, and going through another collar for this assembly. This tab, we're going to reference this tab again on the side. This is going to be the bottom of our gearbox. So this is the top of our gearbox. As our shaft comes down, we need to put a collar on that shaft. Next, our gear will be going in. The collar on the gear is down. So our gear goes into place and you have to maneuver it a little bit. The way these gears, I mean, they mesh really nicely, so the shaft has to come back, the gear drops straight in to where it engages the worm gear, and then the shaft can go through. It's just the way the gears engage one another. And then our last collar goes in. So this, I'm going to line up this bottom collar with its corresponding hole for its alignment. Tighten that down. I haven't secured the gear in place. I'm going to get this top collar I have to get this this set screw on the collar of the gear lined up with the machined divot on the shaft. I tighten that one. Now I'm just manually rotating these gears to get that other set screw to come around. And at this stage, you know, since I'm manually turning this, I can feel that everything is turning freely, and I don't have anything that's hanging up as of yet. All right, I've got that other set screw around to where I can get to it. Okay, so that should be, this gear and this gear are both meshed together, and I can turn it back. And there we go. That's how the rotary positioner works. So for all intents and purposes, that gearbox is functioning and complete. Our next step is going to be, like I said earlier, going to use this gearbox to fixture up the base, which consists of what do we got? 5 pieces, 5 plates. We have our base, our 2 sides, and then front and rear supports for the base unit itself. Basically have to use the gearbox as a fixture at this point, because these where the bronze bushings here stick out the side, they actually travel in this radiused slot here. And we use these shoulder bolts for our pivot. Get one in there. Get our other side on there. And the second shoulder bolt in. So this positioner doesn't flop around on me. I'll use the hitch pin that goes in there to lock in gearbox. And then these plates here just go on the front and the back, just like that. These shoulder bolts do have nylock nuts, so I'm just gonna loosely put those in. So assembling the base once the gearbox is fully assembled is pretty simple. As you can see, those parts just kind of drop in along all four sides of the base next to the gearbox itself. What I'll do now, it's really all pretty fixtured the way it is, so I'm going to put some tack welds in there just to keep parts from falling. I just put a clamp on there with just enough force to keep these parts from falling off. I don't need to square it up for anything. If I pull this pin and if it rotates like that within the base, that's all I need it to do. I think that should be fairly good as far as description of how that base goes together. And so I'll cut away and start tacking this all together so it holds, so it stays together, and then we'll get to some of the final things to wrap it up with the tin covers for the front and the back of the gearbox and the ground strap. Okay, the last bit of assembly that we've got now that the base is all welded up is going to be on the bottom. So we want to rotate the positioner 90 degrees to expose the bottom here, and that's our shaft with the machined and threaded end for our ground strap. First thing we need to do is we're going to locate the two little roll pins that were included with the kit. They go in these little holes here on the bottom. I'm going to tap them in about half the length of the roll pin. I want about 1/8 of an inch of that roll pin sticking out. What those are there for is this is our ground strap, and that ground strap gets bolted to the bottom of that shaft, and to give us a ground that can rotate, we've got this cap screw with a spring on it, and that's going to go on our ground strap and get threaded into that shaft. And we're not going too crazy as far as tightening this. It does have Loctite on it, so basically bury that Loctite, but still have enough play in that spring so this ground strap can turn. That's this bolt basically is going to be rotating whenever this positioner is in use. So the spring is keeping pressure on our ground strap to isolate the positioner and the positioner drive shaft to ground. Now the other end of our ground strap is going to get bolted to this hole in the base right here. I'm going to put the included cap screw through the hole, through the ground strap, and nut it on the back. And this one we can lock down tight because it's not going to go anywhere. So if I pull this pin, the unit should be able to rotate within the base without the ground strap catching anywhere. And the last parts that we have are these sheet metal covers that go on the front and back to basically, more than anything, keep your fingers or debris out of the gear set. And that's what these little plastic Christmas tree push pins are for. Push them in the holes, 2 on the top, 2 on the bottom. That is our completed weld positioner. All together. The end of this shaft is machined to 7/16. You can see with the different speed of the drill, you get a different speed. Obviously, rotating the positioner. This is where the Velcro strap comes in. Pull your trigger to the speed you want it. And set your Velcro strap in place. You're going to have to support your drill, obviously, but now you've got a rotating weld positioner. That's the assembly of this unit. I hope it was informative. Should have covered just about everything. So yeah, following this video and the technical drawings that accompany it in the kit, shouldn't have any problem. Just take your time and check and double check to make sure that these shafts are turning without much effort through the entire process, and you should have the same results I did. Again, thanks for watching. Hope it was informative. If you have any questions, don't hesitate to ask. You can certainly ask where you see this video posted, whether it's on the website or on YouTube, or else you can call or email us if you have any questions about the weld positioner, or if you're getting a weld positioner, if you have any questions in the assembly of your weld positioner. There it is. Not too bad to assemble at all. Thanks. Comment, thumbs up, subscribe, all that good stuff.